Good morning, students. The next topic which we are going to see is about self-induction. So, what is an inductor is? Inductor is a device which is used to store the energy in the magnetic field. So, magnetic field energy store பண்றதுக்காக என்ன யூஸ் பண்றோம்? We are using an inductor. Okay. The typical examples are coils, solenoids, and toroids. So, these are the examples for a best inductor. Okay. So, inductor அப்படினாலே என்னது? Stores the energy. Okay. So, same way, inductor, capacitor, more or less the same. But here it stores in a magnetic field. Inductor, it stores in the magnetic field. Okay. So next is the inductance is a property of inductors to generate the EMF due to the change in the current flowing through the circuit or change in the current through the neighboring circuit. So that is being magnetically linked. So inductance அப்படினா என்னன்னா inductor means it is a device which is used to store the energy, is it not? Inductance means it is used to generate the EMF due to the change in the current. So change in the current நால நமக்கு EMF generate ஆச்சுனா that is called as a inductance. Okay, so inductance is a property which generates the EMF due to the change in the current. So எந்த current அதே circuit நாலையும் சரி or the change in the current through the neighboring circuit, neighboring circuitல produce ஆனாலும் சரி. So that is said to be the inductance. Clear with what is inductor and inductance is? Inductor is a device which is used to what? Store the energy. Okay, so inductor is a device which is used to store the energy, and inductance is a one in which it is used to generate the EMF. Clear? So these are all the example as coil, toroid, and solenoid. Okay, self inductance. So what is meant by self induction is the magnetic flux of the magnetic field is linked with the coil itself. So magnetic flux வந்து அதே magnetic field நால change ஆச்சு அப்படின்னா, okay, so that is called as a self induction. Okay, if the flux is changed by changing the current, so currentனால flux change ஆச்சுன்னா என்ன ஆகும்? EMF is induced. Okay, and this phenomena is called as a self induction, and the EMF is called as a induced EMF. Clear? So ஒரு magnetic fluxனால என்ன ஆகுது? ஒரு magnetic field. Okay, so because of that change in the flux, there is also an EMF which is induced in the same coil. Okay, and that phenomena is called as a self induction, and the EMF induced is called as a self induced EMF. Clear with this? What is the self induction is? So ஒரே coilல அதே ஒரு magnetic fluxனால நம்மளுக்கு வந்து change ஆச்சு அப்படின்னா that is called as a self. Okay, self means within that same coil itself. Okay, so this is a current. So in the current நால என்ன ஆகுது? இந்த magnetic flux வந்து change ஆகுது. Okay, so if this magnetic flux is changing, that is called as a self induction. Okay, so here let us consider, let phi be the magnetic flux, phi of B with the magnetic flux, and be the number of turns அப்படின்னா அப்ப total flux is equal to what? This number of turns into this flux. So we are writing this as n into phi. Okay, so this is what? The total flux. Okay, and that flux is proportional to what? The current. So the total flux is proportional to the current அப்படின்றதுனால n phi is proportional to I ன்னு எழுதுறோம். Now to remove this proportionality, we are introducing a constant. The constant which we are introducing here is L. So L into I. இப்போ நமக்கு இதுல L மட்டும் வேணும்னா we are bringing this term I down. So we are getting L is equal to n phi divided by I, where n is the number of turns, phi is a magnetic flux, I is a current, and L is said to be the self inductance. Okay, so self inductance is denoted by the letter L. Okay, so clear with the equation for this self inductance? Okay, so self inductance is defined as a flux linkage through the coil when unit current flows through it. So this is the definition which we are saying with the help of this equation. Okay, ஏன்னா நம்மளுக்கு தெரியும் Lன்றது என்னது? செல்ஃப் இண்டக்டன்ஸ், n ஃபைன்றது என்னது? ஃப்ளக்ஸ் லிங்கேஜ் அப்படின்றத இங்க கொடுத்துருக்காங்க இல்லையா? தென் I. Okay, I is what? The current, is it not? When we are considering the value of I to be equal to 1, okay, so I oda value வந்து நம்ம வந்து 1 ன்னு வச்சிட்டோம்னா, okay, so we get L is equal to என்ன கிடைக்கும்? N into 5B ன்னு கிடைக்குமா? Okay, L is nothing but what? Self inductance. N 5 of B ன்றது என்னது? Flux linkage. So we can say that self inductance is equal to the flux linkage எப்போ? When the unit current passes to the circuit. So unit current னா என்னது? I is equal to 1. 1 ன்றதுக்கு பதிலா தான் என்ன சொல்றோம்? Unit current ன்னு சொல்றோம். Okay, so when unit current passes to the circuit, the self inductance is equal to the flux linkage. Okay, so see here the self inductance of a simple or a simply inductance is defined as flux linkage of the coil when 1 ampere current flows through it. Okay, so 1 ampere means because we are considering the value of I is equal to 1 இல்லையா, so அப்போ self inductance is equal to the flux linkage. Okay, so clear. So this is a definition of self inductance. Clear. So using this we are going to derive the equation when I is a current, okay, EMF is induced. From Faraday's laws of electromagnetic induction, we know that Faraday's law is what? E is equal to minus d phi divided by dt. Okay, so this is the equation from Faraday's law. Since we are having the n turns here, we are writing this as d n phi divided by dt. Okay, இப்போ தான் நம்ம பார்த்தோம் n phi க்கு பதிலா என்ன எழுதலாம் அப்படின்னு சொல்லிட்டு L into I. So we are writing this as minus d into Li divided by dt. In this L is constant, so we'll be taking it out. So we get just di divided by dt. Okay, so this is the equation for E. Okay, so E is equal to what? Minus d into Li divided by dt. Okay, so using this equation we'll be finding with the next one, which is E. E is equal to minus L into dr by dt. Now from this, if you need the value of L alone, bringing this down, okay, so we get L is equal to minus E into di divided by dt. Same இதுலயும் அதே தான், இந்த வேல்யூ வந்து நம்ம 1 ன்னு வச்சுக்கலாம். ஸோ 1 ன்னு வச்சுட்டோம்னா நம்மளுக்கு என்ன கிடைக்கும்? L is equal to minus E ன்னு கிடைக்குமா? Okay, so L ன்றது என்னது? Self inductance. That is equal to what? Minus E. So minus E ன்றது என்னது? Opposing EMF. Okay, opposes the change in the current. Sorry, self induced EMF always opposes. எப்போ oppose ஆகும்? Change in the current with respect to the time. Okay, so di by dt வந்து நம்மளுக்கு 1 ன்னு கிடைச்சதுன்னா then L is equal to minus E. Okay, so clear. So this is about the next definition for self inductance. Okay, so L is equal to minus E. எப்போ நம்மளுக்கு L is equal to minus E? When di by dt is equal to 1. Okay, clear. So self-inductance is defined as opposing EMF when rate of change of current through the coil is 1 as power minus 1. Okay, so this is the other definition of self-inductance. Clear. So we have the two definitions. First definition is what? L is equal to just L we are seeing, but we are considering only with the current, is not. So using that, if you are seeing, we are getting the formula as L is equal to n phi. So n phi ன்றது என்னது? Flux linkage when current is unity. So this is the first one. Okay, then second one எதனால? E நால. Okay, so L is equal to minus E. எப்போ? di by dt is equal to 1 as per minus 1. Okay, so clear. So this is about the inductance, that is a self inductance. So di by dt is equal to as per minus 1, E is equal to minus 1 அப்படினா then we get the value of L is equal to என்னது? 1. Okay, so L is equal to 1 ன்றது என்னது? Henry. Okay, so inductance of the coil is 1 Henry. எப்ப நம்மளுக்கு 1 Henry கிடைக்கும்? Current changes at the rate of 1 as per minus 1 and there is an opposing EMF of 1 volt. So EMF வந்து 1 volt ஆவும், current changes வந்து 1 as per minus 1 ஆவும் இருந்துச்சுனா then we are getting the inductance to be equal to what? 1 Henry. So inductance is 1 Henry when current changes at the rate of 1 as per minus 1, opposing EMF of 1 volt. Okay, clear. So this is all about the inductance and the self inductance of the coil. Clear.